Stop everything you're doing right now, because what I'm about to tell you is going to completely break how you think about time itself. You've been living your whole life believing a day lasts 24 hours. But on Mercury, a single day, just one sunrise to the next sunrise, lasts longer than half an Earth year. Let that sink in. While you're rushing to meet deadlines, racing against time, stressing about Monday mornings, Mercury is sitting there taking 176 Earth days just to complete one single day. And honestly, Mercury might be onto something. Here's where it gets genuinely mind-bending. Most people assume that because Mercury is the closest planet to the Sun, it must zip through everything fast. And you'd be half right. Mercury does orbit the Sun faster than any other planet. It completes one full trip around the Sun in just 88 Earth days. That's its year. One Mercury year equals 88 Earth days. But here's the controversy, the cosmic twist that breaks people's brains the moment they truly understand it. A Mercury year is actually shorter than a Mercury day. That planet finishes 2 complete laps around the Sun before a single sunrise-to-sunrise cycle is finished on its surface. Repeat that sentence out loud because it sounds like science fiction, but it is absolute, confirmed, peer-reviewed science fact. NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, gave us the most detailed data we've ever had on this planet. The numbers are locked in. Mercury rotates on its axis incredibly slowly. It takes approximately 58.6 Earth days for Mercury to complete one rotation. But because it's simultaneously racing around the Sun so quickly, the Sun appears to move strangely in Mercury's sky. If you were standing on Mercury's surface, you'd watch the Sun rise, then actually stop, reverse direction briefly, and then continue rising again. That's not a glitch in the simulation. That's gravitational physics in action. The interaction between Mercury's orbital speed and its slow rotation creates this bizarre solar retrograde effect visible from certain points on the surface. Scientists call it a solar libration. You'd call it the most disorienting sunrise of your life. Now here's where I want you to pause and actually feel the scale of this. You wake up on Mercury. You make your coffee, metaphorically speaking, because Mercury's surface reaches temperatures of up to 430 degrees Celsius on its sun-facing side. You watch that sunrise. Now you wait. You wait through what would be an entire January, February, March, April, May, and most of June on Earth. You'd go through 6 months of human experience, births, deaths, elections, sports seasons, heartbreaks, viral trends. And when all of that is done, the Sun would finally be setting on Mercury. You're only halfway through one Mercury day. This is not just trivia. This has enormous scientific implications. The extreme length of Mercury's day means its surface experiences some of the most violent temperature swings in the entire solar system. The sun-facing side bakes at 430 degrees Celsius, while the dark side drops to negative 180 degrees Celsius. That's a swing of over 600 degrees between day and night on a single planet. No other planet in our solar system experiences that kind of temperature chaos. Not even the one people always assume is the hottest, and Venus, by the way, wins that title overall with a surface temperature of about 465 degrees Celsius held constant by its thick atmosphere. Mercury doesn't have that atmospheric blanket. It's raw, exposed, and extreme. What makes Mercury even more fascinating is its gravitational relationship with the Sun. Mercury is locked in what's called a 3:2 spin-orbit resonance. For every 2 orbits Mercury makes around the Sun, it rotates exactly 3 times on its axis. This isn't a coincidence. The Sun's gravity has literally sculpted Mercury's rotation over billions of years, pulling and tugging at this small rocky world until its spin settled into this precise mathematical rhythm. It's like the Sun choreographed Mercury's rotation from 77 million kilometers away. That is gravitational power at a scale that genuinely humbles the human mind. And here's the thing that nobody talks about enough. Mercury is actually shrinking. Data from Messenger confirmed that Mercury has contracted by up to 7 kilometers in radius over its geological history as its iron core cooled and shrank. The surface is covered in enormous cliffs called lobate scarps, some stretching for hundreds of kilometers, formed by this planetary compression. This tiny planet, this fast-orbiting, slow-rotating, day longer than its year world, is physically getting smaller over time. Bepi-Colombo, a joint mission by the European Space Agency and JAXA launched in 2018, is currently on its way to Mercury and expected to enter orbit in 2025. Scientists are counting on this mission to deepen our understanding of Mercury's magnetic field, its composition, and the mysteries locked inside its oversized iron core, which accounts for about 85% of the planet's radius. That's disproportionately massive compared to any other planet in our solar system. Everything about Mercury defies your first instinct. Closest to the Sun, but not the hottest. Fastest orbit, but slowest day. Smallest planet, but largest iron core proportionally. It is the ultimate pattern breaker in our solar neighborhood. So next time you feel like your day is dragging, remember that somewhere in this solar system, a single day lasts 176 of yours. Time is relative. Perspective is everything, and the universe never runs out of ways to make human assumptions look small. If this rewired your brain even slightly, follow this page right now because this is exactly the kind of science that will keep expanding your mind every single week. And I'll leave you with this. If you could stand on Mercury and watch the sun rise, stop, reverse, and rise again, what would you name that moment?